All right, to finish this off, Mary Beth. Let me mute that. Mary Beth is looking to buy a home. She can afford $1,000 per month mortgage payments. If she gets a loan from a bank for 25 years at 3.6% interest per year, what is the maximum home price she can afford? So this is the amortization. Actually, I think I skipped 8. I don't think, did I? I'm not sure I did number 8 in the last problem, so I'll come back and do number 8, or in the last video. I'll do number 9 first, since I already read it. No, I'll do number 8. So this is amortization, or the amortization formula is... Well, I know what it is, but I can't remember the letters anymore. Something equals, I don't know what the letter is that goes over there, but it's K times L over 1 minus, parentheses, 1 plus K to the negative n power. Yeah, I forget what the letter is technically on the left-hand side, like the answer part. Anyway, so we're going to fill this in. Oh, yeah. We're going to do that later. Okay, thanks, pal. Let's just change that to like 7. All right, cool. Don't mind me. Not a big deal. Anyway, so she can afford $1,000 per month payment. So over here, this is the monthly payment, whatever letter you want to call this. I forget what letter it was in our notes. Let's call it like Q or something, just because why not? All right, so that's going to be our payment. Our monthly payment is this number here. So we know that Mary Beth can afford $1,000 a month. It looks like $1,600. $1,000 a month. And what we're looking for is a home price that she can afford. So the home price is L. L is the loan or mortgage amount, like the total house loan worth, whatever. So typically the price of your home, not including any down payment or whatever. Anyway, K is our interest rate, 3.6% per year. But remember, we're paying per month on our mortgage payment. So we need to make sure we understand what are the percentages per month. So 0.036 divided by 12 is 0.003. So that's my K value, 0.003 times L, which is what I'm looking for. 1 minus 1 plus 0.003 to the negative n power. So it's 25 years, 12 months for a year for 25 years. So 12 times 25. Crap. Oh, that works. Okay. 300. So negative 300 power. All right. So now, we are going to solve this for L. So think of it like this. All of this here on the bottom is a number. And whatever that number is, I need to multiply it to the other side. So technically, because this is all being divided on the right-hand side. So if I multiply both sides by that, it'll technically cancel out on the right-hand side. But to move it over to the left-hand side, I need to multiply it to that side. So look how I'm going to type this in my calculator. So hopefully you can bear with me. If you did it differently like other times, you're more than welcome to just keep doing that. But alpha, God, I just want to hit the alpha button. Alpha, y equals. All right. Now I'm going to do 1,000 times this because, of course, since it's being divided, like I said, on the right side, I need to multiply it to the other side. So I'm going to do 1,000, and I'm going to multiply it. So times all that stuff that's in the denominator. So I'm going to have a lot of parentheses here. So 1 minus, and then another parenthesis, 1 plus 0.003. Close that parenthesis, raise that to the negative 300 power, and then close that parenthesis. So that is the top. That's the $1,000 times that denominator. Now, let's assume, right, that all of this just got moved over there. So then I've got, the only thing is 0.003 times L. So to get rid of the 0.003, since it's being multiplied to L, I would have to divide this side by 0.003. So that's what my denominator here is for. So I'm going to take that side and divide it by 0.003 and get $197,627.39. So that is the mortgage or home amount that Mary Beth can afford, given, that interest rate, that time period, that amount per month. So yeah, let's go back to number 8. So number 8 is a more typical amortization problem. So where we're looking for the monthly payments. So we don't actually know what, again, I don't remember what letter it is, but we're calling it Q. We don't actually know what that is, but we know everything else. We know K. K is 6% per year, but it says monthly payments. So we're going to take that 6%, 0.06, divided by, oh my gosh, divided by 12. So that is 0.005 for the K value. So it would be 0.005. Times L. L is the 85,000 because that's the loan that I'm taking out. So 85,000. All divided by 1 minus 1 plus 0.005 to the negative n power. So it's 6 years, 12 times a year since it's monthly payments. So 6 times 12. 6 times 12. We get 72. So negative 72 power. So all you got to do is type all this in. All right, 0.005 times 85,000 over 1 minus parentheses 1 plus 0.005 to the negative 72 power. That looks good. So there it is. The monthly payment for that would be $1,408.70. $14.08. Isn't that a movie? I think that's a movie. All right. So now we're going to get into the new stuff. Okay. So describe the payments received by a purchaser of a bond with a $5,000 redemption value at a $4,500 purchase price and stated interest rate of 4.5% per year semi-annually. The bond is purchased 2017 and the redemption date is 2020. Interest is paid every January and July, whatever, up to including the anyway. So what is the return on the bond? All right. On the test, this is going to be a decimal answer. So let me talk you through how exactly we are going to get that. All right, so here we go. Our bond is $5,000 redemption value, and we're getting paid twice a year, 4.5% of that $5,000. But of course, because it's 4.5% semi-annually, we first need to make sure that we take our 4.5%, which is 0.045, and divide it by 2 since it's interest paid semi-annually. So that's my number, right? 0.0225. I need to find that percentage of the $5,000. So take this number that we get as, we can call it the K value, and take it and multiply it with that redemption value, which is $5,000. So multiply that to the $5,000 and $112.50. This is our interest payment that we get every 6 months, twice a year. So I'm getting paid this amount of money twice a year in just interest. So since I'm being given that money twice a year, let's find out how much of that will be over 3 years. So that'll be 6 times, right? If it's twice a year for 3 years, then I'm going to be paid this amount of money 6 times. So $112.50 times 6 is $675. So that's how much money I am going to get just in interest. As well as, don't forget to count the $5,000 at the very end. After 3 years, I'll have made $675 in interest, but I also get the $5,000 bond back. So I'm going to make a total of $5,675. Well, I'm not making that money, but that's how much money I am going to receive or had received by 2020. Now, the thing is, we want to find out our return. So our return is how much money we made from this off of our original investment and the percentage of that. So we want to find out how much more money this is than the 4,500. So if you take your answer, the 5,675, subtract the 4,500, this will tell you how much money you made. So we made a profit. We profited $1,175. Now our goal is to find out what what is the percentage that to our original 4,500? So every time you want to find your rate, or I'm sorry, your return, right? The rate of return, you're going to take the profit you made and divide it by your original deposit or original amount, whatever it is. It's always going to be how much you profit divided by its original amount. So the 1175 divided by the 4,500 will give us the percentage return divided by 4,500. And that's 26.1%, or we can just say 26% return. So I'm buying $4,500 bond, and at the end of 3 years, I will have made 26% of that amount of money back, I guess. Of course, I'm getting the original amount back, but I'm making 26% more, if that makes sense. So let's look at number 11. Erase all of this because it's kind of annoying. Number 11, what is the return on investment of a share of stock which is purchased $36.75, held for 4 years, and then sold at $51.75? So we want to find out the profit again. So we're not really looking into how much money I'm buying, like how many stocks I'm buying, because of course I could buy like 1,000 stocks and it can be a lot of money. I'm just looking at the percentage of growth. So it doesn't really matter how many stocks I buy, the percentage of growth would be the same regardless if it's, the stock price goes from this value to this value. So let's see. If I started with $36.75 as an investment and I sold my stock for $51.25, how much money am I making per share? So let's just take the difference of that, right? If I'm, bought it for this amount and I sold it for this amount, well, then how much money did I make? So 51.25 minus the 36.75 is $14.50. So this is my profit. This is how much money I'm making per stock. That's my profit. But I'm looking for the return on my investment as a percentage. The rate of return, I guess, is really a better way of saying it. So just like I wrote it before, I don't know if I still have it up there or not. No. But the rate of the percentage is the profit divided by your original make or income. It gets cut off there because the paper's not there. But anyway, divided by the original amount, which is 36.75. So 1450 divided by 36.75, right, is 39.5%. If you want to think of it, it's about right if you move that decimal. 39.5% growth is what we're making there, which is pretty good. Now, that's over 4 years, though. Keep in mind, that is not the answer, so I circled it. I'm going to see how many people get it wrong now, but because it's like, oh, look, he circled 39.5%. I'm going to put it on my paper, and they don't actually listen to the video. That's over 4 years. So if you want to find the annual rate of return, which, again, it probably should say this in the problem, the annual rate of return is taking this and dividing it by 4, because this is over 4 years. So you want to know what it was per year, then take that number, divide it by 4. And that's going to be right about 9.9%. Again, move that decimal place and round a little bit. It's about 9.9%. Now, I'm not going to write that down. I want to see how many people put 39.5% on their paper because they don't listen to the video. 9.9% per year. Okay, over 4 years, it's 39.5. But anyway. All right. Last problem. Laura is considering buying 100 shares. I'm just going to round this, instead of reading all this, let's just summarize it. So the current stock price is $11. Current price is $11. I'm going to do a little bit of math here, and I'm going to figure out if it's worth investing in the stock. If the expected value of my stock is higher than $11, then it's worth investing in. If it's not higher than $11, then it's not worth investing in. So what is the future outlook for this? So we got a chocolate company. They're coming up with a new candy, and the probability the candy sells well, the probability is 0.4. If it sells moderately well, the probability is 0.5. And if it tanks, the probability is 0.1 of that happening. So it's a pretty good chance that the new candy will be a success, but there's a 0.1% chance that it will just fail entirely. All right. Now, what are the values associated if it does well? If it does well, we expect the stock price to climb to $16 a share. If it does moderately well, expect it to climb to $13 a share. And if it fails, the stock price, we're expecting it to drop to just $4 a share. So as far as expected value goes, you multiply the probability with the value for all of these, and then you add up the total for all three of them. So 0.4 times 16 is 6.4. 0.5 times 13 is 6.5. And 0.1 times 4 is 0.4. So add up all three of these. 0.4 plus 6.5 plus 6.4 is 13.3. So the expected value is 13.3. Now we're not done. Let me scroll down a little bit. We're not done because, again, we're looking at the rate of return. I don't know if that's what it was. Yeah, expected return on investment. So I guess the word return is kind of the emphasis that it means a percentage. So imagine it's kind of like the last problem now, where we bought it for this much and we sold it for this much. So let's play along. Let's say I bought the current stock at $11 a share and I'm expecting 13.3 out. Well, if I bought it for 11 and then sold it for 13.3, how much money am I going to make per share? Well, 13.3 minus 11 is 2.3 per share. So I'm going to make 2.3 per share. But again, this is my profit. I'm profiting 2.3 or $2.30 per share. What is my return rate? Well, let's take the 2.3, which is my profit, and divide it by my original investment amount, which is $11. So what rate is 2.3 or $2.30 from $11? So take 2.3 divided by 11. I put a 0 in there unnecessarily. Oh, crap. Let's just clear this and start over. 2.3 divided by 11. This has never been so difficult. And we get 20.9. Again, if you move that decimal place around a little bit. So 20.9% return rate growth, which is pretty good. This stock definitely seems worth investing in. Because, again, this is an expected value. It's probably not going to be exactly 20.9, but the point of doing this in the real world is to identify risk. This stock is not really that risky in investing in, so it's probably a good place to put your money and get a decent amount of return, at least in the near future. So it's more of a risk assessment thing than it is like an actual thing, because we're not predicting stock values. It's impossible to predict stock values, but we're predicting risk, and that's possible to do. So anyway, that's it for this video. Hope it helps. And if you need anything, just let me know. I'll see you guys later. Good luck on the test.